Welcome back to The Explainer. Let's just dive right in, shall we? Because look, if you've spent even 5 minutes glancing at tech headlines lately, you already know the AI boom is completely transforming how we work, create, how we live. It's undeniably exciting. But behind the scenes, behind all those magical generative prompts and lightning-fast algorithms, there's a massive, hidden infrastructure challenge, and it's got the entire tech industry absolutely scrambling. We're talking about a physical, logistical bottleneck that threatens to cap all this incredible growth if we don't fix it right now.
And that brings us to the elephant in the room, the massive energy bill. The sheer scale and complexity of the infrastructure needed to just train and run these advanced AI models requires massive, and I mean literally unprecedented energy resources. We're reaching a tipping point where the traditional way we've always built and powered data centers, it's just not going to scale anymore. The grid can't handle it, and quite frankly, the budgets can't handle it either.
So what does this all mean? Well, it leads us to the core dilemma. If you're an IT director, a data center manager, or a systems engineer, here is the exact puzzle keeping you up at night. How do we actually harness this incredible potential of AI without blowing past our operational budgets or leaving behind a completely unsustainable ecological footprint? Because let's face facts, the old method of just stringing together rows and rows of servers in a freezing cold room, it simply cannot handle the incredibly dense computing power that modern AI requires.
Section 1. A sustainable engineering blueprint.
To solve this, we're looking at a fantastic resource published by Academic Press called Making It Sustainable: Techniques and Applications. The really crucial point here is how this book reframes our entire mindset. Instead of just giving us some high-level philosophy on why we should save the planet, this text serves as the ultimate practical blueprint for modern data center operations. It defines sustainability not as a compromise, but as a core, totally solvable engineering challenge. It zeroes in on conscious design choices, strict energy efficiency measures, and responsible practices for long-term development. It basically perfectly bridges the gap between what we want to achieve environmentally and what we actually have to achieve operationally on the data center floor.
Section 2. The cooling revolution.
Now, anyone who's ever walked onto a server floor knows that traditional cooling is a huge drain on the local power grid. Traditionally, we've tried to keep everything icy cold using these massive evaporative water towers. And that uses a tremendous amount of water and power. But there is this incredibly elegant shift in design happening right now. By allowing servers to operate and vent heat at higher temperatures, companies can completely ditch those heavy consumption water towers. Instead, they're switching to high-temperature dry coolers. It's a real game changer, just a completely different zero water waste way of thinking about heat management.
Now, for the skeptics out there thinking, okay, sure, but does that actually move the needle financially? Well, the numbers are absolutely staggering. NVIDIA projects that a 50-megawatt hyperscale data center can save over $4 million annually just by making the switch to these high-temperature, liquid-cooled, and dry-cooled infrastructures. Let that sink in for a second. $4 million. That's a massive operational savings every single year, just from rethinking how we handle heat.
And you see, this brilliantly illustrates the core argument of the entire text. True sustainability isn't a cost center. When environmental benefits are achieved through smart, foundational engineering, they directly boost your bottom line. You aren't just saving water and reducing carbon emissions to look good on a corporate sustainability report, you're actively driving down the cost of your AI deployments. Environmental benefits and financial ROI, they go hand in hand here.
Section 3. Smarter power distribution.
Okay, so now that we've cooled things down, we have to efficiently feed these servers dense power. Because in a traditional setup, you have these constant AC to DC power conversion steps happening right inside standard server racks. And every single time you convert that power, you lose energy in the form of heat, which, as we just learned, is the enemy. The text highlights a major shift here, implementing direct current or DC power architectures directly inside the data center. By eliminating those wasteful conversion steps and bringing DC power straight to the equipment, you drastically improve energy efficiency and really slice down that operational overhead.
Now, combine that highly efficient DC architecture with this awesome concept detailed in the text, airside economizers. Instead of fighting the ambient temperature all year long and running heavy, power-hungry mechanical refrigeration, smart, sustainable data centers are using these systems to literally pull in external ambient air. They're leveraging their local climate to naturally cool the DC equipment. Depending on where your data center is located geographically, relying on the outside air rather than mechanical chilling can deliver absolutely substantial energy savings. It's so smart.
Section 4. Ready for the feature?
So, putting this all together, If you're managing enterprise workloads, designing cloud architectures, or just trying to figure out how your company is going to deploy its next AI cluster responsibly, this information is absolutely vital. It is definitely time to stop guessing at your green infrastructure roadmap. This text provides actionable, real-world data center solutions that bridge the gap between high-level corporate sustainability goals and day-to-day engineering execution. If you want to dive deeper into the exact schematics and strategies we covered in this explainer today, I highly recommend picking up a copy of Making It Sustainable: Techniques and Applications on Amazon. It's an invaluable tool for modern IT professionals.
Which leaves us with one final critical thought to ponder as you look ahead to your upcoming deployments. I want you to take a hard look at your current systems and ask yourself, is your data center infrastructure truly ready to handle the sustainable AI revolution? Because the future of computing isn't just about who has the smartest AI models. It's about who has the smartest, most efficient, and most sustainable foundation to run it on. Thanks so much for joining me for this explainer, and I'll catch you in the next one.